fungi have always lived in symbiotic relation with the plant roots. Mycorrhizal fungus forms a living connection within the roots and creates an absorption and transport system. This is essential for healthy plant growth. Mycorrhiza in the roots is just as normal as chlorophyll in the leaves. This is beyond doubt. As stated before, the absorption roots of plants are 0.2 millimeters thick. This means that they can only grow in macropores, as shown here. Now we zoom in to see what happens when the plant gets help from the mycorrhizal fungus. The fungal threads are even thinner than most bacteria. They are only as thick as 3 microns. This means that these thin threads grow easily in the micropores, where the majority of nutrients and water are stored. Without help, a plant would never be able to reach these areas. It's not just the roots, but also the fungal threads that are responsible for the absorption of nutrients and water. The long, thin fungal hyphae that fully takes over the absorption of materials from the roots are able to provide disease resistance. Distantly located minerals that are bound to iron and calcium are now easier to absorb. These fine threads or hyphea can easily be a kilometer long in just 1 teaspoon of soil. Mycorrhizal fungi cause absorption capacity to be 7 times higher on average. This means that growing can be done with less water and that weeds have far less chance to thrive due to competition for space. The benefit to the fungi is the glucose produced by the plants. For the plants, the benefit is a larger absorption zone. This unique and constant interaction between the plant, bacteria, and fungi creates a really fantastic symbiosis. The payout that the plant provides to its partners is water, minerals, and glucose. The partnership between soil and roots requires healthy soil biology. Healthy soil contains organic matter from dead leaves, dead roots, and dead animals. This dead organic matter is broken down in nature by soil life to become humus. This creates a great deal of food for soil life, and the soil retains plenty of CO2. Years of using fertilizer has caused the humus to disappear from agricultural land. You could think of humus as the battery of the soil. It's where the energy is stored, the energy that the soil life needs to do its work. Without the humus, it is almost impossible to achieve natural soil recovery. It has long been thought that nitrogen fertilizer stimulates the soil life as more bacteria are able to grow. But to maintain their carbon-nitrogen balance, they are compelled to consume more organic material, which then enters the atmosphere as CO2. The symbiosis between plant, fungi, and bacteria is not only a great partnership, it is absolutely vital. Without these transformers of organic material, we would all perish in excess organic material. Returning to the question we asked previously about how we can improve the soil, the answer must be, ultimately, plants improve the soil on their own. They do this through the symbiosis between plants, bacteria, and fungi. Plants are really the only soil improvers. Here we can see a clear difference between an absorption system without and with mycorrhiza fungi. The plant on the left is entirely dependent on the pH value of the soil and the supply of minerals. The plant on the right has roots that are able to optimally self-regulate the pH level and absorption via mycorrhiza fungi. This results in a healthy absorption that works perfectly with organic fertilizers. Using this natural system, we will achieve healthy soil that in turn brings healthy plants that can produce healthy fruit and vegetables. The way we deal with our soil has a direct effect on the emission of CO2 and the nutritional value of our food.